Okay, question 11 then. So the table shows information about the amount of money spent by the first 80 customers visiting a shop on Saturday. Complete the cumulative frequency table. So for cumulative frequency, all we're doing is adding the frequencies as we go. So we've got less than... Ooh. And again, slight issue with these. Those should all say 0 for a cumulative frequency. So that should be 8. Cumulative frequency for the next one should be 20. Then we're looking at 39. Then we're looking at 39 plus 17, which is going to be 56, I believe. We're then looking at 56 plus, so that will be 69, and then 80, provided I've done that right. Okay. On the grid, draw the cumulative frequency for the polygon. So the cumulative frequency, we plot each of these at the end of the graph. Right, so what I'm going to do just to help me out here, so I'm going to snip that onto another page. Okay, that'll do, I guess. There we go, perfect. Okay, so at 20, I'm going to plot the 0.8. So, and as soon as I tap on that, that's going to disappear. So I'm going to put it on my second screen. Right, and at 40, I'm going to plot 20. At 60, I'm going to plot 39. At 100, no, sorry, I've missed one out. At 80, I'm going to plot 56. And then at 100, I'm going to plot 69. And then at 120, I'm going to plot 80. And then I need to join them up with as smooth a curve as I can. So let me just double check what the data was. So the data does imply amount spent could be 0, so it would be 0 would spend 0, so I can join it up to 0. So join it up with as smooth a line as I can. Oops. So that's roughly my graph. Obviously, you should be able to draw a slightly smoother one than me. Just checking my values. That looks fine. Yep. Okay. On Saturday, the median spend of the first 80 customers was £25. Compare that to the median time spent of the first 80 customers. So if we've got 80 customers, we're going to use 50 to work out my median. So from the graph, I'm going to go at 40. I'm going to go across until I hit my graph, and then I'm going to go down. So it's just above 60. 62 looks like a reasonable estimate. Maybe slightly less. We'll go 62 though. Compare this to the median. So that's actually the median we were asked to compare. So it seems like I might have miscalculated somewhere. We're comparing £62 to £25. So assuming that's right, although it's giving me a little bit of anxiety, I'm thinking that might be wrong because there's such a big gap. Saturday's median is much higher. And then I'll quote the figures, £62 versus £25. Right, 5 marks for that then. Let's have a look. So if we go back to the cumulative frequency table, and again, did have issue with the table slightly. Just that for cumulative frequency, these should all be 0. Let's have a look. That's 11A. They agree with my totals though, and it's just an A1 for all filled in correctly. For the cumulative frequency graph, then M1 for at least 4 points plotted correctly, and then an A1 for all points joined by a curve. So in effect, we've got M1 and A1 there. And then for the second part, median on Sunday was 61, although it says allowing anything in the range 60 to 63. So it's M1 for finding the median, although anything between 60 to 63 is acceptable. And then the statement is the median on Saturday was much higher. The median is Saturday's median is much higher, would be absolutely fine for that. So A1. Okay, question 12. Here are three pentagons. The area of pentagon B is 50% greater than the area of pentagon A. The area of pentagon C is 40% greater than the area of pentagon B. Write down the ratio of area of A, area of B, area of C, giving your answer in its simplest form. Okay. So let's go A, B, C. So if the area of that to, well, I'm going to start with ratios like this. So to get from there to there, it's 50% greater. We're times in by 1.5. And then if I just kind of think about this, actually, I'll do it this way. 1.5. And then if I go area of B to area of C, I've got 1 and then greater, 1.4. And then I'd need to kind of combine these. I'm going to combine them with a ratio of 3. So that one would times by 2. And actually, I'm going to alter this in a minute anyway. I need to times this one by 3. So that would give me 4.2. So I can't really have a decimal within there. So I need to get rid of that. So I'm going to times by 5 to get rid of that. So that would give me 10 to 15 to 4.2 times by 5 would give me 21. So, and I can't simplify it down, so it's going to be 10 to 15 to 21. So that's not necessarily the only way you could do it. That's the way I would probably do it though. Let's see, mark scheme, I might pick up a better method. Okay, so they have suggested, they've suggested an interesting, I don't think it's a better method. They've suggested working it in terms of a percentage, so saying that that's 100%, that would be 150%, and then 150 times by 0.4 would give you 210, and then they've simplified that ratio down, which is okay, yeah. I think that's a fair way of doing it. No major difference. So we'll go, it says M1 for scaling. Actually, that's probably should be M1 there. M1 there. M1 for writing it as a ratio, and then an M1 for simplified ratio. So that's my 4 marks. Okay, question 13. Write 6 over x plus 2 plus 5 over x minus 1 as a single fraction in its simplest form. So in effect, not going to overly complicate this. What I'm going to do is put it over the same denominator. So the denominator is going to be x plus 2 times by x minus 1. And to do that, I would need to times that fraction by 6. That fraction by x minus 6. X minus 1 even. So that's going to be 6 lots of x minus 1. Plus 5 lots of this. So 5 lots of x plus 2. And then if I simplify that, so 6x plus 5x is going to give me 11x. My number part then is minus 6 plus 10 minus 6 plus 10 is going to be plus 4. And I'm not going to multiply at that. I'm going to leave it as factorized. So I'm going to leave it as x plus 2 times by x minus 1. Okay, the second part then. So simplify fully, and this is quite a nice one on a higher tier. If this comes up on Friday, I'll be very happy. Reason being that we're factorizing on the bottom, I would be able to do without a hint of the top line anyway, because we've got just an x squared. So factorizing my top line, we've got a difference of 2 squares, so it's x plus 4 times by x minus 4. And my denominator then is going to be going to 2 brackets, both starting with an x. Two numbers that multiply together to make minus 24 and add together to make minus 3 are going to be minus 7 and 4. And then they would cancel, giving me just x minus 4 over x minus 7. So marks for that then are awarded as follows. So an M1 for the numerator or the denominator correctly factorized. So for this one, M1 for either the numerator or the denominator correctly factorized. Sorry, I'm looking at the wrong mark scheme there. For this one, M1 for correct common denominator. So M1 for the correct common denominator. It then says an M1 for the numerators of that part and that part, so M1 for the numerators, and then an A1 for correct simplify. For part B then it says M1 for either correct numerator or denominator factorized, so I can pick it up just for the top line factorized. It then says an M1 for both numerator and denominator factorized correctly, so second M there, and then the A1 for the final part. Okay, question 14 then. Ooh, interesting. There we go. Okay, so on the grid, show by shading the region that satisfies. So I don't think it would state that in an exam anymore. It would say show the region rather than shading. But that's no major drama. So the first thing I'm going to do is I'm going to be careful of how I draw these because we've actually got different inequalities to show. Just as a recap, if it is a less than or greater than, we would have a straight line. If it's or equal to, we would have a dashed line, which I haven't seen come up on a paper at GCSE anyway. And I've done that the wrong way around. It should be dashed and full. That should be dashed and that should be full. And again, I've done that twice. I was right the first time. Dashed, full. I'm dating myself far too much today. Less than or equal to is it's like a liquid. It can be, so that would be full. Can't be equal to means we have a dash. That's the reason why. So, second time I was right, not the first time or the third time. Okay, so my first line is going to be a dashed line at y is equal to 1. So y is equal to 1 would be that line, so I need a dashed line there to start with. Then I've got x plus y is equal to 6 is the one that I want to do. So when y is equal, straightforward coordinate on there is if x is 0, y would be 6. So when x is 0, y is 6. And then when y is 0, x would need to be 2x would need to be equal to 6, so x would need to be equal to 3. So again, you're going to draw this with a ruler rather than freehand like myself. So I'm sure I could do this better with a ruler. So in effect, oh gosh. Okay, so with a ruler, just to try and get that a bit neater, and roughly going to be my line. And then my final one is I've got an intercept of 3 and a gradient of 2. So every one across, it's going to go up 2. So for every one across, I'm going to go up 2 by my graph. And for every one back, I'm going to go down 2. So that's going to be my third line. So we've got dash. So the region is going to be the middle, the section in the middle. If we think about, well, I'm going to assume it's that one and then just check that that coordinate satisfies all of the parts. So let's pick a better coordinate. Let's go for 1, 2. So when x is 1, y is 2, does that satisfy all 3 equations? So the first one is y is greater than 1, so y is greater than 1. 2 plus 4, that 4 is less than 6, and then 2 is less than 5. So that satisfies all regions. So normally we would just identify the region, but the question did say shade in the region. But I don't think you'd find that on your GCSE spec. It would probably just say identify the region. Okay, mark scheme for that then. So we have got 1 line correctly drawn, M1 all 3 lines correctly drawn, A1 correct region shaded. So let's go straight forward. That was the first one that I identified. So M1 all 3 lines correct gets me the second M1, and then an A1 for the correct region identified. Okay then, question 15. This shape has been made by removing a small semicircle from a larger semicircle. Work out the perimeter of the shape, given your answer in terms of pi. Okay, so bits that I'm going to look at. So first of all, that length and that length is going to be equal to 10 minus 4, so that length plus that length would be 6. Then I'm going to work out the perimeter of both semicircles, or try to, and I'll kind of color code it just to make it clear. So that blue line is going to be equal to pi d over 2. So pi times by 10 divided by 2, or 5 pi. And then we'll color code the final one green. So that line there is going to be pi times by 4 divided by 2. So that's going to be 2 pi. So the total area, let's keep color codes going. We'll go orange. So I'm going to add all 3 parts together. So 5 pi plus 2 pi plus 6 is going to be 7 pi plus 6. Right, I need another colour to mark. We'll go purple. Okay, so it's an M1 for working out the outer perimeter. So they're awarding M1 there. M1 for working out the inner perimeter, M1 there. And then M1 for adding the 3 together. And then an A1 for 7 pi plus 6. Okay, question 16 then. Right, question 16. So David wants to find an estimate for the number of fish. So capture, recapture. I've done this recently with my year 11s because I think it will be on one of the papers. On Monday he catches 80 fish. He puts a mark on the fish and returns them to the lake. So I tend to do this as fraction. So out of the entire population, 80 a quarter. And I know normally we'd have the fraction the other way around, but it just helps me in terms of the working out. On Tuesday, he catched 120 fish, 6 of which were marked, so that's going to be equivalent to 120 over 6. So x is going to be equal to, and this is why it just saves me a step when I'm simplifying. So 120 divided by 6 is going to be 20. So it's 20 times by 80. So my estimate is going to be 1600, so 1,600. And then the marks awarded for this are picked up for M1 for the fraction that way around or the other way around, an M1 for working it through, and then an A1 for 1,600. Okay, question 17. Circle theorems, one of my least favourite topics, but here we go. So let's have a look. I use circle theorems to show that AC is the diameter of the circle. So instantly what I am thinking is that I'm going to be working, I want to show that that's a right angle triangle. So for it to be a diameter, that would need to be a right angle. And I think we can do it like this. I can say that that angle there, so CAD, would be equal to 23 degrees. And then I'm going to put my reason there. So that is angles from a chord make the same angle at the circumference. So angles from a chord make equal angles or the same angles at circumference. And then from there, we've got two angles in a triangle. So angle CDA is going to be equal to 180 minus 23 minus 67, which is going to be 180 minus 90, which is going to be 90 degrees. And the reason for that are angles in a triangle equal 180. In a triangle equal 180. And then finally, so AC must be the diameter. As diameter makes 90 degree angle at circumference. Must be a diameter, as I should probably put only the diameter makes a 90 degree angle at the circumference. Okay, so marks for that, what have we got? So it starts by saying angle CAD is 23 degrees, angles in the same segment are equal. Angles from a chord make equal angles at circumference, so I'm going to go M1 for that. Actually, it says M1 for 23 there. It then says M1 for showing that that's a 90 degree angle, but then it says B1 correctly stating angle subtended by the diameter is 90 degrees, so AC is the diameter following correct working. Okay, so it's for that final statement for the B1. For the 3 marks, not a bad circle question. Kind of relied on 2 bits of knowledge about circle formulas. The fact that angles from the same chord are equal, made with the circumference, and that diameter creates a right angle at the circumference. Okay, third question. So third question, and rationalising the denominator. Again, another topic I've done with my Year 11s very recently because I think that this will be on the paper. So your method for this is going to be, I'm going to tidy up this first of all. I think. Actually, no, I won't. I will stick with it as it is. So what I'm going to do is I'm going to times both parts by root 50. Root 5. So if I times both parts by root 5, I would get 2 root 60 times by 5 is 120, minus root 15 times by root 5 would be root 75, and that's going to be divided by 5. Right, so 120, I'll rewrite this like this. Okay, so 120 is 3 times 40. Okay, so I've made a mistake here. Root 60 times by 5 isn't 120. Root 60 times by 5 is 300, which makes a lot more sense. So I'm looking at 100 times by 3, and I've got 25 times by 3. So square root of 100 is 10. So that would be 20 root 3, and that would be 5 root 3. And then 20 minus 5 root 3 is going to be, and that's still over 5, sorry, I missed that out. So that's going to be 20 minus 5 is going to be 15. So 15 root 3 over 5, and then that's going to be 3 root 3. So I'm looking at 3 root 3. And marks for that are picked up for M1 for multiplying the numerator and the denominator by root 5. So that picks up that M1 straight away. And then M1 for that line there. M1 for that line there. And then A1 for that point there. Right, question 19. Given that, so read straight away like a complete of the square. So it says, given that x squared minus 6x plus 15 is equal to x minus a squared plus b for all values of x, find the values of a and the value of b. So if I'm trying to put that into a square bracket, so my square bracket is going to have an x in it and half of this value, so minus 3. And then if I bring this 15 down, if I square this bracket out, I would get x squared minus 6x plus 9. So I need to minus 9 from it to keep the size the same. So tidying that up, then I would get x minus 3 all squared plus 6. So find the values of a and b. So technically a is going to be equal to, it says minus a, so that would be a is equal to 3 and b would be equal to 6. And that's complete the square. That is quite viewed as quite a tricky topic. Hence write down the coordinate of the turning point. So the turning point is when this value is going to be 0. So the turning point is going to be when x is equal to 3. And when x is equal to 3, y would be equal to, the first bracket would give you 0. So that squared would give you 0. So y would be equal to 6. So that's the coordinate of the turning point. Explain how this would show that there are no solutions to the equations. So we've got a positive quadratic. So we've got a positive quadratic with a minimum turning point where y is greater than 0. So very basically, positive quadratic means a U-shape like that, and the fact that the turning point is still in the positive y direction, it means that the graph can't go below the x-axis. Turning point where y is greater than 0. So I think that's enough for the mark. We'll find out in a second though. Right, so marks for that we are picking up. For part A, it is so M1 for that bit there, and then an A1 for that bit there. It is just a B1 for the correct turning point. And then what does it say? The turning point is above the x-axis and the coefficient of x squared is positive. So that's exactly what, well, not exactly, positive quadratic, which is what x squared coefficient means. And then the turning point is above the x-axis, so with a minimum turning point where y is greater than 0. And that's B1. Right, question 20. I was just thinking we haven't had a functions question yet. Oh, okay. So work out the value of f to the minus 1 of 44. So to do this, first of all, I'm going to work out f to the minus 1 of x. So in effect, I find the easiest way to do that is if I start out with the function of x and call it y for now. So y is equal to 3x plus 2. I rearrange to make x the subject, and then in effect that x is the inverse of x, so y would then become x, and then x would become f to the minus 1 of x. So what we end up with is y minus 2 divided by 3 is equal to x, which means the inverse of it would be x minus 2 divided by 3. So f to the minus 1 of 44 is going to be equal to 44 minus 2 divided by 3, or 42 divided by 3, which is going to be 14. Right, 14. And for the second part, solve f of x of g of f of x. So we need to put the function of x into x. So if I say that g of f of x, first of all, is going to be equal to 3x plus 2 all squared plus 3x plus 2, that will give me g of f of x. So that's, when I square that, that will give me 9x squared plus 12x plus 4 plus 3x plus 2. So that gives me 9x squared plus 15x plus 6. Right, and I might not have room to do it up here, but I'm going to try and do it up here. So I'm going to put that equal to 0 then. Oh, my numbers are going everywhere. Plus 6 is equal to 0. Right, if I divide through by 3 first of all, that gives me 3x squared plus 5x plus 2 is equal to 0, which is much easier to simplify, to factorize, because that was a 5, not a 3. Because I can only factorize as a 3x and an x, and I can only factorize to get 2 by having a 2 and a 1. I just need to work out which way around they go to make 15. To make 5, and that would be 2 there and 1 there. Giving me my two values then are going to be, to make that bracket 0x would need to be equal to minus 2/3, and to make that bracket 0x would need to be equal to minus 1. So that's going to be my two values. Let's just write that slightly clearer. Right, lots of marks there. Let's see how that goes. Okay, and marks for this, let's see if we can pick up some marks. For the first bit then, so M1 for finding the inverse, M1 for substituting in, and then A1 for 14. And then for the second part, M1 for this line here, M1 for simplifying it to this, M1 for attempting to factorize, and then an A1 for the two values. And on to question 21. Okay, here's a cross section of a swimming pool. 2m, 5m. Okay, the top of the pool is horizontal. To begin with, the pool is empty. Water flows into the pool at a rate of 20 litres per minute. Water flows into the pool for 20 hours. 1 metre cubed is equal to 1,000 litres. Find the depth of water h measured at the deepest point of the pool after 20 hours. Okay. So if we look at saying that the volume, so I'm just trying in my head to decide the best strategy for this. So let's just start. So I'm going to start by working out how much volume is going to be put into the pool, volume of water. So if it's 20 litres per minute, there are 60 minutes in an hour. So that's how much would go in 1 hour. Sorry, that's how much would go in 1 hour. So in 20 hours, we would have that many. So that's going to be 24,000 litres would go in, which is going to be 24 metric cubes or meters cubed is going to go into the water. So that's going to be the volume of the water. Right. What I'm going to say then, so this isn't necessarily the best way, and I'll see how this works out. What I'm going to say is, whatever this height is, this height here, so is going to be equal to, well, that gap there is 0.8. So this, the height of this part, so if I put it there, is going to be h minus 0.8. So I'm going to say that the volume of the pool is going to be equal to a half of h plus h minus 0.8 times by the height 10 times by the width, which is 5. So if I say, I'm going to mess around with this a little bit, so I'm going to actually say that that means that 24 is going to be equal to 2h minus 0.8, and what I've done there is halve that value times 5 times 5. So 5 times 5 is 25, so that's going to be 24 over 25 is going to be equal to 2h minus, and if I convert that, I'm going to call that 0.8 is 4/5. Right, so in effect, if I want to add that on here, so I'm going to say 24 over 25 plus, if I times that by 20, that would, times that by 5, that would be 20 over 25 is equal to 2h. So that's going to be 44 over 25 is going to be equal to 2h. Divide that by 2, so h is going to be equal to 44 over 50. So I think it's going to be 44 over 50, which can be simplified, 22 over 25. Yeah, I'll say 22 over 25 meters. Am I happy with that as an answer? I think that's quite a complicated fraction. I could go in the direction of going decimal, so if I double them both, 0.88 of a meter, I think would probably be a better answer. Let's just have a look. So we've got decimal here, so yeah, I'm going to go 0.88 meters. 0.88 meters would be the height. Right. If we go to the mark scheme for that then, so it is suggesting M1 for 24,000 litres, so M1 for working out the volume of liquid. They've followed a similar method to me. M1 for H minus 0.8 identified as the height of the shallow end, so I did that there. Okay, an M1 for, they've actually said an M1 for that being equal to 24, so I'll award it there. M1 for attempt to solve H, so I'll say that's my attempt to solve H, and then an A1 for 0.88. And that brings us to the end of that paper. Pretty decent paper. I think in terms of a predicted paper, there's not a lot that there are definitely some topics that I predict are going to be on. I think there'll be a functions question. Not sure about that. I do think that there'll be a simplifying surds and rationalising the denominator combined question. I think a fair bet that there'll be a circle formula question on there. I do think there'll be a capture recapture, hit or miss with this one. I do think there'll be a simplifying fractions, algebraic fractions. That's a good bet. Yeah, I think this is a pretty decent paper. Hopefully you've done okay on that. Because it's a predicted paper there, and because it's not done by an exam board, there is no predicted grade boundaries. If I just look at the mark scheme, I'll just have a quick look, see whether they've suggested anything in terms of grade boundaries. They haven't. So hopefully you found that useful though. I think it's a good stage for revision. Thank you very much for taking the time to watch the video. Feel free to add any comments or questions in the thread, and I will see you soon.